All right, so today we are going to be talking about how to graph a parabola that doesn't have any zeros. This is number 10 in the worksheet included for today's assignment. Now, this is on the second page. This is not part of the actual assignment. Only page 1 is part of your assignment. But if you do want to complete some additional problems on your own choice, then you can definitely work on page number 2. So this is how we graph parabolas that don't factor or don't have any zeros. So if we wanted to factor this, it would be 0 is equal to, I'm going to change my a value to be positive. That means I'm going to multiply everything by -1. Well, that means that we have to find factors of 30 that add up to 10. And the closest we can get to that is going to be 6 and 5, which adds up to 11. So it's just not going to work. So this means we're going to have no zeros, which means it's not going to be on the x-axis. But what we can do is we can find the axis of symmetry, the vertex, and then go old school and create a table. So let's find the axis of symmetry. I'll abbreviate axis of symmetry. Okay, so it's going to be x is equal to -b over 2a. If I go back to my original problem, my b value is -10, so it's going to be the opposite of -10. Over 2 times -1, and I eventually get -5. So my axis of symmetry is going to be -5. So let me draw that. X is equal to -5. All right, so now using this x value, I can plug it in to find the y value of the vertex. So let's do that. If I have -x² minus 10x minus 30, I'm going to plug in the value of -5. First, I'm going to jot down the original problem, and then I'll fill in. There we go. It's easier to find out. So again, we're finding the vertex right now. So we get -5 squared is 25, so we get -25. -10 times -5 is 50 minus 30. Whoop, there we go. Then we get 25 plus 50 is 25, minus 30 is equal to -5. So my vertex is going to be -5, comma, well, -5. And this comes from right here. This comes from right there. So we can graph that, -5, -5. All right, so we want to establish, is this going to be opening up or is it going to be opening down? So we look at our a value. Our a value is negative, so it's going to be going down. And yelling timber. Okay, it's going to look something like that. So we can create the quote-unquote old school table method with x, y, and we want to choose for this one 5 values. I'm going to start out with my vertex smack dab in the middle. So we already graphed that. What we now want to do is choose 2 values to the left of the axis of symmetry and 2 values to the right of the axis of symmetry. Well, if I'm going to the left, I have -6 and -7. Likewise, -4 and -3. Now, whatever I get for -3 as my x, it's going to be the same as my -7. Whatever I get for -4 is going to be the same for my -6. Okay? Because the axis of symmetry shows that it's going to be symmetrical. So if it's symmetrical, then it's going to be the same distance away from that axis of symmetry. So now we just take these x values and plug it in to our original. So we have -x² minus 10x minus 30. And we're going to plug in all these x values. When we plug them in, what we get is actually -6, -6, -7, -9. So for -4, it's going to be -6, -3 is going to be -9, and we can graph these now. So -6, -6. Notice how I'm 1 unit away from the axis of symmetry, so I'm going to be 1 unit away from this axis of symmetry. And then if we were to have a -9 on the axis, it would be somewhere around here. So now we can graph it. Nope, I wanted blue for that one. Come on now. There we go. Oh, look, something like this. Okay, and now the last thing that what we can do by identifying is we can say, okay, well, what is the minimum or the maximum value? Well, since I'm opening down, right here is going to be my max. And the max is going to have a value of -5 because that's the y value of this parabola, the highest y value of this parabola. Notice how we're getting lower as we go down the y-axis. Hopefully this helps. If you have any questions, please reach out. You're doing so well. Keep up the great work. Have a good one.